Welcome to Internet Quality Academy. The channel is for the civil engineer, quality control engineer, and the site engineer who are working in the construction field. In this channel, we are discussing about the construction, quality control, and everything which is required to get success in the construction. Today also, we are going to discuss about a very important topics, that is what you need to check before slab casting, because slab is the structural element and you need to check it properly and precisely to get the structural integrity. So stay tuned until the end to get the full information about what to check and how to check before slab castings. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's start with inspection checklist before slab casting. This is a general guidelines, but you need to incorporate your data as per your project requirement or your project specification, and you need to prepare a comprehensive checklist as per your requirement. But this is the guidelines. If you can follow this one, it will be helpful for you. The first things for the slab, what you need to check, that is the formwork inspection. The what in formwork inspection, what we need to check first? Design approval. What does it mean? That means formwork is also need to be designed by the competent authority and it should be approved by the concerned authorities. What does it mean? That means formwork to be designed and it is to be submitted for the structural engineer or the designer approval. And this design along with the document, along with the drawings, should be approved by the designer or the structural engineer. So whenever you are there, you need to first check whether these two documents is available or not. So if these two documents is available, that means design is done and approved by the designer, and the drawing is also done and approved by the designer, and it is available in the site. Then we need to check the alignment and the element of the formwork. In the formwork, we know that there are different elements, from base jack, from the standard, laser, vertical element, horizontal element, diagonal bracings, across bands, main beam, supporting beam, plywood, clamp, joint details. Yeah, each and everything what is mentioned in the drawing, we need to check that everything or every element is in place and accurately labeled and align. What does it mean? If it is not labeled, that means we are not getting the concrete at the right place, because every slab has their own top of concrete or the bottom of concrete. We will check whether this bottom of concrete is, or the formwork top level is equal to the bottom of concrete. Then we will get the right kind of slab as per the alignment or as per the designer document. So first thing, design approval, then the alignment, and every element is in place, that we need to check. Then it is secure fastening. Ensure formwork is securely fastened and owned, shipped during pouring. This is also very much important, that every joint is properly fixed, so that during the movement of the people and during the vibration or concrete pouring, it should not displaced or it should not shift, so that we will get the right kind of structure and the structural integrity will be assured. So these three things we need to check: the design, alignment, level, every element is in there and every element is securely fastened and joint details are proper. And another things in the formwork we need to check, that is the third party approval. For the formwork, client or consultant will ask that the who are doing this design or who are the expert on the formwork, they will come and they will inspect and they will give on approval letter that this formwork is erected as per the design and as per the document, as per the drawings, and it is safe to pour the concrete. And along with this letter, we need to submit to the client and the consultant. So these are the formwork inspection we need to check whenever we are doing slab casting or before slab pouring. Then after formwork, what will come? Of course, it will come reinforcement. In the reinforcement, what we will check first? First things, we will check that the BBS approval. What is BBS? That is the bar bending schedule. It is the detailed about the steel reinforcement of diameter, length, placing, shape, and each and everything in details. So first things, we need to check whether the BBS has prepared and BBS is approved by the concerned people or maybe the consultant or the client. So we will take that BBS, and along with this BBS, we will go to the site for the checking. And what is BBS? How to prepare BBS? On that matter, I made a detailed video. Link is there or in the description. Please check and you will get all the information about the BBS or the bar bending schedule. Then it is coming builder work drawings. What is builder work drawings? means builder work drawings means in the slab, we don't have only the reinforcement. We have the electrical conduit to be passed, we have the drainage point, we have the sleeves, we have the any insert plate for the future. So these all the things need to be incorporated in the single drawings, and this single drawing is called the builder work drawing. So we need to check whether this builder work drawings is prepared or not and it is approved or not. So along with BBS, we will go with the builder work drawings. That means everything, MEP, structural, architectural, everything is incorporating and every details in there inside that drawing. So we will check with along with the BBS and the builder work drawings. Then we'll go for the checking slab reinforcement. First reinforcement, what we will check? We will check the beam reinforcement. Why? Because the first things what we check in the reinforcement, that is the beam. We first place the beam, we tying the beam bar, then slab bar. So first we will check the beam reinforcement, and in the beam reinforcement, what we will check? Top bar, bottom main bar, shear bar, extra bar, and also where the beam lap is provided, because everywhere we cannot lap in the beam. It has the specified zone according to the criteria of loading and the loading pattern of the beam. So that's why we need to check whether the splices zone is as per the design or as per the document or not. So how to check the beam splices zone? I have made a detailed video on that. Check there or in the description. You will get an idea that what is the beam splices zone and how to calculate the beam splices zone. So that is also we need to check whether the lap or the splices in the non-splices zone that we need to the splices zone that we need to check in the beam reinforcement. After beam reinforcement, we need to check for the slab reinforcement. Now, in the slab reinforcement, we need to check in two times. One is a bottom layer, another is a top layer. Why? In the bottom layer, we will check, and if we find anything wrong, we can tell them the rectify. Or if it is checking after the top layer, it is very much difficult to rectify in the bottom layer itself. So first things we need to check the bottom layer, and if the bottom layer is okay, then only we will allow them to lay the top layer. And also the MEP conduit and anything so only will be placed after the bottom layer. So first bottom layer, then top layer. In the top slab reinforcement, what we will check? The slab diameter of the bar, spacing of the bar, lap location, lap splices, any extra bar, crank bar is there or not. That all we need to check in the slab reinforcement according to the BBS and according to the drawing. So after slab reinforcement, we need to check the column reinforcement. Column, what is main bar, stirrups, and also we need to check beam column junction because it is a heavily reinforcement. So we need to prepare a shop drawings so that how this all beam reinforcement and the column reinforcement will place, and this stirrup bars, maybe 2 legs, 4 legs, 6 legs, whatever as per the drawing, that need to be incorporated in a single drawing. And according to the single drawing, we will check that all the reinforcement are in place or not. Also, what we need to check in the column reinforcement, that the link bar is properly tightened and finished. Also, the hook, that whatever its angle should be 135-degree, that is mentioned in that is in there or not. That is also we need to check in the column reinforcement. Then it is coming extra reinforcement and cutout. In any slab, we need to passing the MEP utilities so that we keep some area in open. So we need to cut out that area, and in the cutout, we need to provide the extra bar for the structural integrity and the structural stability. So we need to check in that extra reinforcement are placed and not at the cutout. So this will also we need to check. Then it will come bar placement, spacing of bar, lap length, development length. Down. So development length also something else, and the lap length something else. I made a detailed video on this as per IS 456, how you can calculate the development length. Check there or in the description box, you will get full information about the development length. So we need to check that when the beam column junction, when the beam reinforcement is entering into the column, that the development length is provided or not. Maybe it's a 50D, 4070, whatever. Also the lap length, it's 40D or 4070 or 50D, that is provided or not. And the lap should be in the splices zones only, not in the non-splices zone. That we need to first find out which is a splices zone and which is a non-splices zone. Accordingly, we need to check that one at the side. So these are all about the reinforcement. And then after formwork reinforcement. Now we need to check embedded items. What is embedded item? Sleeves and inserts. Check that sleeves and inserts are correctly placed for the future installation. Sleeves may be the MEP utility pipes will be passing through them. So we need to check as per the builder or drawings or as per the MEP drawings that all the sleeves are in place or not. And any insert plate is there because maybe for the architectural finish or the structural finish, we need to place the insert for the future load or future extension. So we need to check whether the insert plates are in place or not. That also we need to check insert plate size, insert plate thickness, insert plate center spacing, everything we need to check in for the embedded item. Then utilities, confirm that any utility conduits or pipes are in place and protected. Maybe electrical piping conduiting will be there, or the drainage pipe will be there. So we need to check that are all in place and properly tightened so that during the concrete it will not get damaged or not get misplaced. If it is damaged, then it is a disaster that during the conduiting or wearing we will not be able to perform the work and it become a disaster. So we need to check the all are in place and is protected so that it will not get damaged during the concreting. So these are the embedded item we need to check whenever we are checking the slab before pouring. Then it is coming the joint details. What are the joint details? That is the expansion joint or it may be the construction joint. So if the expansion joint is there, we need to verify the placement of expansion joint according to the design. First, we need to check the location of the expansion joint is as per the design, as per the drawing. Then whatever the treatment of the expansion joint, maybe the extra bar or whatever the extra things we need to provide it, that is there or not, that is also we need to check. Then construction joint. First things, we need to finalize where we will give the construction joint, and these also we need to prepare a shop drawing or the pouring sequence, that these are my pouring sequence and these are my the construction joint, and that will be approved by the client or the consultant, and according to that approved drawings we will provide the construction joint. And we need to check that the construction joint are in place and ensuring construction joint are correctly positioned and whatever the details is there that are placed or not. So these are the joint details also we need to check whenever we are preparing or checking the slab before the concrete pouring. Next is coming after joint details, it is coming weather condition. Now we have checked the formwork, we have checked the reinforcement, we have checked the MEP, everything, we have checked the joint details. Now we need to do the concreting. So before the concreting, what we need to check? We need to check the weather condition. One weather condition, why we need to check? We need to check the temperature, we need to check the wind pressure, we need to check the rainfall, snow or sunny, that we need to check. If the temperature is too high, if it is not within the code specified limit, then we cannot do the concreting. And if there's a heavy wind, we are not allowed to start the concreting, because if it is a heavy wind, there is a very difficult to perform the concrete procedure, and there may be thermal cracks or sinkage cracks can happen. And if it is raining, if it's a snowfall, that also we need to check whether the weather condition is favorable for the concrete or not, as per the design document, as per the codes or as per the project spec. So we need to check that one also. If it is okay, then only we can start the concrete. So after whether we checking, we need to check the accessibility. What is the accessibility? That is access point. Ensure that there are proper access point for concrete trucks. Now the concrete trucks will come, we need to check the quality control of of the concrete. So there will be access point or the quality checkpoint. That also need to ensure that the quality checkpoint and the ensuring that the truck is moving through smoothly inside the site, or it has no hindrance for the concreting. So we need to check the concrete checkpoint and also the ensuring the concrete trucks can move easily. Then the workability concern, confirm that the site allows for easy maneuvering of tools and equipment, which is very important, that whenever we start the concreting, we cannot stop that one. So what we need to do before the concreting, we need to check that the truck can move easily, that the moving of the any tools or equipment, that's been vibrator or any other things can easily accessible in the area. That also we need to check. And along with the concrete checkpoint, and along with concrete checkpoint, there should be slump, there should be cube mold, there should be thermometer or any other requirement for the testing. That also we need to ensure that everything is in place, and if it is in the place, we will allow them to concrete. Now these are the accessibility. Then it is coming surface preparation. If it is in the ground floor, we need to check in a very careful manner that it will rest, the formwork is rested on the soil. So we need to check the confirm that the subgrade has the right moisture content and ensure proper compaction of the subgrade. So these two things also we need to check if it is in the ground floor, that the moisture content and the compaction or the degree of compaction is as per the requirement. Otherwise the structural stability is will be a problem during the concrete. So these are also for the surface preparation we need to check. Then it is a concrete test. As I also mentioned, that what the test you need to check. First we need to check the mix design is approved or not, and that mix design as per the project specs or not, that also you need to check. Then verify slam cone, thermometer, cube mold or any other test equipment available, and all the equipment are calibrated and is in use. It is not that a calibration is 2 years back, 3 years back, so it is no use. So it should be the calibration certificate and it should not expire. That all everything we need to check for the concrete test. And the concrete test also we need to check that who is the person doing the concrete test. He is well trained and he is capable enough. Also we need to ensuring for the concreting. So these are the for the concrete test. And then another point is safety precaution. Safety first. Now, whatever, whenever we are doing work at the site, we need to be very careful that safety is first. So we install safety barrier around the construction area, which is done or not, that is also need to check. Then PP, that is personal protective equipment. Ensure workers are equipped with necessary PPE. That means you need to check everyone is wearing the PPE and everything. And along with that, we need to check whether all the worker are give them training or not, be it in the safety training or in the quality training, and they are well aware about the construction sequence, construction procedure, concrete procedure, and each and everything, how to vibrate or how much time to vibrate. If each and everything is communicated to the workers, so that whenever they will work, there will be no negative impact on the work. So these are the things you need to check whenever you are checking the slab reinforcement or slab formwork before the slab castings. And I hope you find this useful. And if you find this useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your comment, for your valuable comment. Everybody will be benefited. And if you want to know anything more about construction and quality control, please let me know. I'll be happy to come with more content like this. Thank you once again for watching me.